Okay, if you are working with a rational function where the numerator of the polynomial is less degree than the denominator, then when x gets extremely big, either big in the positive direction, like x equals 100, 1000, or the negative direction, x equals negative 100, negative 1000, the denominator is going to grow so much faster with large x's that this function will have a horizontal asymptote of 0. The only functions we're focused on in classwork 5-6 and homework 5-6 are rational functions where the numerator is less degree than the denominator, and you have a horizontal asymptote of y equals 0 because of that. On Monday, we're going to take a look at when the horizontal asymptote isn't 0. But first, we want to become clear with these models. So, yesterday we learned about finding x-intercepts. X-intercepts happen when y is equal to 0. A fraction will only equal 0 when its numerator is 0, so we get -1 for the x. Y-intercept is something that happens when x is equal to 0. So if I plug 0 into all the x's, I'm going to get 0 plus 1 over a -2 times a +2. So I'm going to get a y-intercept of -1/4. And then yesterday we also learned finding vertical asymptotes means looking at what makes the denominator equal to 0. And this is in factored form. So solving each factor equal to 0, we get 2 vertical asymptotes of 2 and -2. And I just want to point out that neither of these values of x where I have vertical asymptotes, neither of them make the numerator 0. I'm not going to be giving you problems where the numerator and denominator are 0 for the same x. That's an additional thing to learn once we get comfortable with the rest of it. Now, today you are learning that because the numerator is less degree than the denominator, what is the horizontal asymptote? Oh, and what happens if they're the same degree? That'll be Monday. Sorry. What is the horizontal asymptote if that numerator is less degree? What is the horizontal asymptote? Correct. Thank you. Now, listen to me carefully about creating the sign line. Listen carefully. First of all, if you read the directions, you're creating a sign line using the values of x that make either the numerator or the denominator 0. So what are the numbers that make either numerator or denominator 0? We can see that one of those is -1. Another one is +2, and another one is -2. Do you feel comfortable with those are the only 3 values of x that make either the numerator or the denominator equal to 0? Now the thing is, this function can go through a sign change of its y value. It can cross over the x-axis and have a positive y value versus a negative y value. It can only change at these x's. So the graph is either existing entirely underneath the x-axis or entirely above the x-axis. And that's going to save you a lot of grief of not having to point plot. So what you're going to do is you're going to write these numbers in proper order of a number line and just list them on this line. So -2 is the smallest. of the three, -1 is next, and then 2 is the largest. I'm not concerned about the spacing that I put between these numbers. I'm not trying to make an accurately drawn number line. I just need these numbers to be in their appropriate order, because I can then focus on all x values smaller than -2 are going to produce either a positive or a negative y value, and we have to figure out which one it is. Then, when I am in between -2 and -1, the function lies either above the x-axis or below. And same thing with between -1 and 2, and the same thing with greater than 2. Now, if you notice shorter ways of doing things, I will say there are shorter ways of doing what I'm about to show you, but I know that I need to explain it in this way first. So what you're going to do is you're going to pick a number, any number, greater than 2. So what number would you like to pick that is greater than 2? Your choice. 4, 6, okay? 8. What you're going to do is you're going to plug that number into the x's of the function, but you don't have to overly calculate. You just need to know, is it positive or negative? So what I would recommend you do is focus on linear factors.
That becomes 3 over 0.
If you do what?
If you do 2, it becomes 3 over 0.
Right. And so what I want to not choose, I don't want to choose the numbers I put on the number line. I'm not going to use -2, -1, or 2. I want to pick numbers in each section, because any number I pick that's greater than 2 is going to come up with the same answer of, is the function positive or negative? So any number you want to pick, we're going to come over here, and it's easiest if you look at it as, is it positive or negative? So go with the number you chose. Maybe you chose 4, maybe you chose 6, maybe you chose 2.8385. What really matters is when you plug that number into x and you add 1, are you getting a positive number or a negative number? And your answer is, you are getting a
Positive.
yes. You got it. See, you're getting there. Which I could just write a little plus sign. That would be easier. I just wanted to make sure that you knew what I was drawing. Can you choose 0? Yes. But you are choosing numbers that are in each individual interval. So while I'm looking at x values larger than 2, I have to pick a number larger than 2. But when I'm between -1 and 2, I can pick 0. 0 is in there, and we definitely want to use it if we can. So what you want to see is you have 4 intervals of x, and you can pick any number within each interval, and you're just trying to figure out if the function comes up positive or negative. That's it. So if I plug in something larger than 2, I have a positive numerator. If I plug in something larger than 2, is x minus 2 a positive number or a negative number? If I plug in 4, if I plug in 6, I'm getting positive for this factor. That positive factor will then multiply by this other factor. If I plug in a number larger than 2, like 4, 6, 8, 2.8385, am I getting a positive or a negative number? And you probably see positive. So that means in my denominator, when I multiply two positive numbers, I get a positive denominator. My numerator is positive, so a positive number divided by a positive number is a positive number. And this is going to help you tremendously when you graph the function, and I'm going to take you very slowly through that. We're going to do this for each section. So now we're picking any number between -1 and 2. 0 is a really nice number to pick. And I'm coming back over here to the equation. And I'm starting again. If I plug 0 into this x, is the numerator positive or negative? What do you guys see? If I plug 0 into the numerator, just the numerator, I think you might be ahead of me. For just the numerator, if I plug in 0, I get positive. In the denominator, if I plug 0 into x minus 2, I get negative. If I plug 0 into x plus 2, I get positive. In the denominator, I have a negative times a positive, so I have a negative denominator. My numerator is positive, so that means that all the function values, when I plug in an x between -1 and 2, all the function values are coming up as a negative number. Now, this next interval, I don't have a lot of choices that are nice. -1.5 is a number that's in between -1 and -2. But know that you don't have to do the full calculation. You can save yourself a lot of time if you realize that your only concern is whether the factors are coming out positive or negative if you plug that in. So if I am plugging in the number -1.5 into x and then adding 1, am I getting a positive or a negative number? I'm getting a negative number. If I plug -1.5 into the x for x minus 2, is x minus 2 a positive number or a negative number? And you guys see negative. If I plug -1.5 into the x in the factor x plus 2, do you see that the factor will come out as a positive? So that means that my numerator is a negative number. In my denominator, when I multiply a negative times a positive, I get a negative. And a negative divided by a negative is what kind of number? You tell me, what kind of number do I get with negative divided by negative? I get positive. So I'm going to put a plus right here. Now I can pick any number I want that is smaller than -2.
-3.
All right. So let's look at -3. And I'm going to erase what I have here previously. So x equals -3. -3 plus 1, positive or negative? Negative. I feel like you guys are responding in your head, right? At least. Okay. All right. -3 minus 2, is that positive or negative? Negative. -3 plus 2 also negative. So for this fraction, if I plug in a number like -3, I get a negative divided by a positive because of the two negatives multiplying for the denominator, and that ultimately gives me a negative. Now, follow me very, very, very closely. You are going to create a graph with this information, and it is enough information for you to actually draw a decent graph of what's going on. Not perfect, but decent. Now, what I'm going to do is I'm going to draw in blue dashes the asymptotes that we have found. So let's go back and look at the asymptotes. We have vertical asymptotes of +2 and -2, and a horizontal asymptote of 0. So the vertical asymptotes at 2 and -2, I am drawing those little dashed lines. And then horizontal asymptote at 0, I'm drawing a little dashed line there. And if it helps, maybe I need to make that a little bit thicker. Can you guys see that okay? Maybe this helps. Now, understand that you must follow these asymptotes. There's no way around it, and that's what's going to help us a lot in drawing this graph. The next thing I want to plot are, I found x and y intercepts, so let's plot those points. So I got y-intercept is -1/4. Okay, yeah. -1/4. My x-intercept is -1. The most important of those 2 points is your x-intercept. The y-intercept just is a nice, easy point to find, but it's the x-intercepts that are going to really profoundly help you with this graph. Because, are you ready? That's my drum roll. Are you ready? If you plug in a number smaller than -2, you are on the left side of the first vertical asymptote. If the y values are only negative, if they are only negative, that means that you are only existing in this region. But more than that, you have to follow the asymptotes. When you're on the left end of a graph, you have to follow this horizontal asymptote. If you have only negative y values, do you see that your graph has to exist under that asymptote and be heading up toward it? Then it's going to be just kind of curvy as it goes from that horizontal asymptote over to the vertical asymptote of -2. But do you see that on the left side of the vertical asymptote -2, you have to head down that asymptote, not up? The graph does not exist where y values are positive if you are on the left side of -2. When you put that together, you get a beginning of the graph of this rational function. Isn't that exciting? Now I'm going to erase the highlight, and I've got a nice little graph left. Now, the next two asymptotes, or the two middle asymptotes, -2, +2. Can you draw the final graph in blacks? Okay, it's easier to see in black. I'll do that then. Come on. Yeah. And I want to make sure it's clear, I'm not plotting any points right now. All I'm doing is getting an approximation. I just realized that's not going to work with the red still there. I'm just drawing an approximation of this rational function. Because I have to exist with negative y values, my graph has to follow the horizontal asymptote underneath and this vertical asymptote down on the left side of that vertical asymptote. On the right side of the vertical asymptote, when I go back to the number line, when I am between -2 and -1, I am only above the x-axis. Now, that's not a very big region, but what you have to understand about rational functions and their vertical asymptotes are that each individual side of that vertical asymptote have to be followed either up or down. If I am dealing with positive y values to the right of -2, I have to be heading up. So I have to be heading up. And then I hit this x-intercept here. But then I learned that after the x-intercept -1, I'm existing under the x-axis. I am existing down here, and that supports the y-intercept that we found. Now, there's a vertical asymptote at +2. On the left side of that asymptote, I have only negative numbers. That means I have to head down the vertical asymptote on its left end. Now, in between asymptotes, you're going to notice some polynomial-ish looking behavior. But I say ish because polynomials don't follow asymptotes. But when you're dividing two polynomials, there is some resemblance to them that you're going to see. Now I'm going to erase the highlight. And then I'm going to come over and look at what's next. And that is when x is greater than 2, I only exist above the x-axis. So I must exist somewhere through here. And I'm going to try and redraw that so that you can see better. There we go. Okay. Now, the right side of x equals 2, I have to go either up the asymptote or down the asymptote. If I have a positive y value only, I have to be heading up it. Then, when I'm in the right end of the graph, I'm having to follow my horizontal asymptote, and I'm either above it or I'm below it with these rational functions. And because I know that I have only positive y values, that means trying to draw, there we go. That means that I'm above that horizontal asymptote. Now, I want to reemphasize the only actual plotted points were the x-intercept of -1 and then the y-intercept of -1/4. We plotted no points, but we trusted the number line as far as whether I'm above or below the x-axis, along with the fact that I have to follow those asymptotes. Combining those two together gives a very powerful reason for the graph going the way that it goes. So I'm now going to show you what the graph actually looks like from a computer-generated drawing. And my graph is not that exactly, but it is that essentially, basically. So that is our first example, and I have two more to take you through. Are you ready for the next two? On a test or quiz, will we need to know how to find other points than the proved ones in the equation? The only points you're expected to find on these graphs are x and y intercepts. That's it. There is no other specific point you need to know. You just need to be located correctly above or below the x-axis. And then you have to follow the asymptotes. So I've got two examples, and I'm going to go faster through these examples. X-intercepts. X-intercepts are what makes the numerator equal 0. Nothing will make 8 become 0. Y-intercept is what I get when I plug 0 into my x's. And hopefully you can see that that's going to give you 8 divided by negative 10. And 8 divided by negative 10 simplifies to a negative 4/5. So almost negative 1, but not quite. Now, to find my vertical asymptotes, I need to determine what makes the denominator equal to 0. So we're going to use that knowledge of how do I factor a quadratic to determine the vertical asymptotes. And I'll go through the diamond thing with you. So 1 times negative 10 for the top, and then negative 3 for the bottom. What are two numbers that multiply to make negative 10 and add to make negative 3? And almost, though, to get the negative 3 for adding them, yeah, you got it. The bigger number needs to be positive or negative. So a negative 5 and a positive 2. And know that you can save yourself time. If I have just a leading 1 there, this is telling me exactly how it factors. When I factor the quadratic of the denominator, it is specifically x minus 5 times x plus 2. Now, the vertical asymptotes are the numbers that make those equal 0. So what are my vertical asymptotes? Mm-hmm. 5 and negative 2. Horizontal asymptote. The numerator, 0, you got it. The numerator is a degree 0 polynomial. The denominator is degree 2. As long as the denominator is a larger degree than the top, you have a horizontal asymptote of 0, because if you plug in positive 100 or negative 100, that's going to be close to 0. Then we're going to make a sign line based on only the numbers that make the top or the bottom of that fraction equal 0. Nothing makes the top 0. The bottom is 0 at 5 and negative 2. So I'm going to draw in 5 and negative 2 in their correct order on a number line. And then I'm going to test any number greater than 5. So pick any number greater than 5, and we're going to test it. And it is easiest to test in the factored form. So that means that I want to look at when the fraction is 8 over the factored denominator. Now, the good news, top's positive no matter what my x is. That just saves me time. Now, pick any number greater than 5. Your pick. What number do you want to put in that's greater than 5? Okay, 6. Perfect. If x is equal to 6, is x minus 5 a positive or a negative number? Positive. If x is equal to 6, is x plus 2 a positive or a negative number? Positive. So that means with 3 positive things multiplying and dividing, my y values are all going to be positive if my x that I plug in is bigger than 5. Now, the next thing I'm going to look at is pick a number between negative 2 and 5. What's a nice number between negative 2 and 5? 0. So we're going to test x equals 0 and see if it gives us a positive or a negative number. And I want to repeat that it is easiest in factored form. You don't need to calculate. You just need to determine if each factor is positive or negative. So I'm plugging in x equals 0. Numerator is positive because it's 8. 0 minus 5 is a negative number. 0 plus 2 is a positive number. So ultimately, I'm getting negative for the y value. And finally, one more section. Pick a number smaller than negative 2. Any number smaller than negative 2. Take your pick. Negative 4. So I'm going to come back over here. And I'm going to change this to x equals negative 4. My numerator is still positive. Negative 4 minus 5 is negative. Negative 4 plus 2 is negative. So altogether, the fraction is coming up with positive numbers. Now, I'm ready to graph. The first thing I'm going to draw are the asymptotes. So I'm coming back over here and I am drawing. Horizontal asymptote is 0. And you know, I want to make that a little bit thicker just to see better. And then my vertical asymptotes, negative 2 and 5. I have no x-intercepts. I have a y-intercept of almost negative 1 that can help me with graphing. So I've got this y-intercept down here. But the big thing is this number line. Based on this number line, I'm going to highlight where the graph must exist. When x is less than negative 2, I have to have positive y values. When x is between negative 2 and 5, I have to have negative y values. And when x is greater than 5, I have to have a positive y value. I also know that my graph has to follow the asymptotes. So I'm going to start on the left end. On the left end, I have this horizontal asymptote. What is my pen doing? I'm not trusting it right now. Okay. So over here on this left end, I'm either right above the asymptote heading down or right underneath the asymptote trying to head up. I am one or the other. Because I know that I have to have positive y values, I know that I have to be above it heading down toward it. For each vertical asymptote, you have to think of it as a left side and a right side. On the left side of the asymptote, my graph is either heading up or it is heading down. Because of what I know with the positives and negatives, it's heading up. So I get that the graph is basically looking about like this. Next, the right side of the vertical asymptote -2 is either heading down or up. Based on what we know from positive negative, it's heading down. And I know it goes through this y-intercept, but somewhere it's got to turn around and come back down. I don't expect you to find where it turns around. I expect you to realize that on the left side of the vertical asymptote 5, it must head down the asymptote, not up. It does not head up because my graph doesn't get to exist there. Each side of the vertical asymptote, I'm either heading up or down. And now I'm going to just use my imagination for where this graph exists and comes back down. You are not plotting exact points. If I plug in anything greater than 5, I am above the x-axis. So vertical asymptote 5, the right side of it, I'm either heading up or down, and I can tell that I must be heading up. Then the horizontal asymptote, I am either heading to it from above or from below, and based on the information, I have to be above it. And whee, and I get a graph. You are now able to graph some rational functions. Isn't that exciting? All right, one more example, and I'm keeping an eye on the time because we get out of here in 10 minutes. Okay, I'm going to have to quickly move over to the answers because you need time for your quiz. So, so what you're going to do for number 2, the x-intercept is what makes the numerator 0, that's 0. The y-intercept is what you get when you plug 0 into x, that's 0 also. If you factor the denominator, you get x plus 4 times x minus 4, and that gives me vertical asymptotes of positive 4 and negative 4. And because the numerator is less degree than the denominator, I have a horizontal asymptote at 0. Then with the number line, you're going to put on there 0, negative 4, and positive 4, and then determine for each of these 4 sections whether you're getting positive or negative by slowly looking at these 3 factors. Once you determine what that is, you then go about graphing. And I want to point out to you that I am actually crossing the horizontal asymptote right here. My functions can cross horizontal asymptotes. They will not cross over a vertical asymptote because that's an x coordinate that's flat out missing from the domain. But you can cross those horizontal asymptotes, so be aware of that. The asymptotes are really only there to express end behavior. They do not tell you what goes on when you're not at an end. So I'm going to release the quiz, and I hope you have a good weekend. Panic. Okay. Okay. Deep breath. Deep, just nice. Breathe calmly. Use the best you can with your logic. Remember, multiply by denominators. And I'm going to post that link and